a big area in the ocean where a lot of garbage is piled up. The Great Pacific Garbage Patch, where a huge collection of trash floating in the ocean. It is primarily composed of plastic waste, indicating a significant environmental issue. This massive collection of debris is located in the central North Pacific Ocean. It's a clear example of the world's trash problem, waste management challenges, and their impact. The patch highlights the urgent need for improved waste reduction and recycling efforts worldwide. The Great Pacific Garbage Patch is not a solid island of trash, but a dispersed area of plastic. It consists of countless plastic particles, many smaller than a fingernail. These microplastics float just beneath the ocean's surface, making them difficult to see. This creates a plastic soup effect rather than a visible landmass of debris. The patch highlights the pervasive nature of plastic pollution in our oceans. Plastic waste primarily originates from land-based sources, posing a significant environmental threat. Common examples include discarded items like plastic bottles, food wrappers, and fishing gear. These materials are often improperly disposed of or lost, entering waterways and coastal environments. Ultimately, this land-based plastic makes its way into the ocean from coastal areas worldwide. Plastic debris entering the ocean becomes subject to powerful rotating ocean currents. These currents act as a primary mechanism for the distribution and accumulation of marine litter. A significant example is the North Pacific Subtropical Gyre, a major oceanic current system. This gyre is characterized by its large, slow-moving, whirlpool-like circulation pattern. It effectively traps and concentrates floating debris within its rotating boundaries. Such gyres are responsible for the formation of vast ocean garbage patches. Ocean gyres are large systems of rotating ocean currents. Their circular motion creates a powerful vortex in the water. This vortex effectively traps lightweight floating debris from surrounding waters. The debris, often plastic, becomes concentrated within the gyre's boundaries. This process prevents the trapped material from dispersing or exiting the area. The Great Pacific Garbage Patch is a vast accumulation of marine debris in the North Pacific Ocean. It is not a solid island, but a dispersed area of plastics and other waste. Its estimated surface area is approximately 1.6 million square kilometers. To put this into perspective, its size is roughly 3 times that of France. This immense scale underscores the significant environmental challenge it represents. The patch highlights the global impact of plastic pollution on marine ecosystems. Plastic pollution in marine environments often forms large accumulations, known as patches. Analysis of these patches reveals that larger plastic items constitute 92% of their total mass. However, microplastics account for 94% of the total number of individual plastic pieces. This disparity highlights a significant process of fragmentation within the plastic pollution. Larger plastic debris breaks down into numerous smaller microplastic fragments over time. The total weight of plastic within the patch is estimated at 80,000 metric tons. This mass is equivalent to the approximate weight of 500 large jumbo jets. This metric serves to quantify the immense volume of accumulated waste. It highlights the significant environmental challenge posed by plastic pollution. Oceanic gyres accumulate vast quantities of plastic debris, forming highly polluted regions. These areas are characterized by exceptionally high concentrations of microplastics. In the most contaminated zones, hundreds of plastic pieces can be found per cubic meter of seawater. This density signifies an overwhelming presence of plastic relative to marine organisms. The sheer volume of plastic debris literally outnumbers the marine life in these patches. Such extreme microplastic concentrations pose significant threats to ecosystem health and biodiversity. Plastic pollution poses a significant threat to marine ecosystems globally. Sea turtles often mistake floating plastic bags for jellyfish, a primary food source. This misidentification leads to the ingestion of harmful plastics by marine animals. Microplastics are consumed by small fish and zooplankton, forming the base of the ocean food web. Ingested plastics can cause a false sense of satiation, leading to starvation and nutrient deficiency. The accumulation of plastics disrupts marine food chains and endangers diverse species. Abandoned fishing nets, often called ghost nets, pose a significant threat to marine ecosystems. These discarded nets drift indiscriminately through oceans, continuing to fish uncontrollably. Marine animals, including dolphins, seals, and sea lions, become entangled in these nets. Various seabirds are also vulnerable, often getting trapped and unable to escape. This entanglement leads to widespread mortality, severely impacting marine biodiversity. Plastic debris in the ocean acts as a sponge, absorbing harmful pollutants from the surrounding water. These pollutants include persistent organic compounds like DDT and PCBs. The plastic concentrates these toxins to levels far exceeding those in the water itself. Marine organisms mistakenly ingest these toxic plastic particles. Once ingested, the concentrated poisons enter the marine food chain, impacting ecosystems. Microplastics, tiny plastic particles, are ingested by small aquatic organisms. These smaller organisms are then consumed by larger fish, transferring the microplastics. As this process continues up the food chain, the concentration of microplastics increases. This phenomenon is known as biomagnification, leading to higher toxic loads in predators. Ultimately, top predators, including humans, accumulate significant levels of these harmful chemicals. Organizations like the Ocean Cleanup deploy innovative technologies to combat plastic pollution. These systems utilize large, U-shaped floating booms designed to collect debris. The technology harnesses natural ocean currents to passively concentrate plastic waste. This method efficiently gathers plastic without actively chasing it, reducing energy consumption. Functioning as artificial coastlines, these systems effectively collect and remove plastic from the ocean. Interceptor systems are deployed in rivers to combat plastic pollution. These systems are strategically placed in highly polluted waterways. Their primary goal is to prevent plastic waste from reaching the open ocean. Stopping plastic at this early stage is more efficient than ocean cleanup. This approach offers a cost-effective solution for environmental protection. Long-term environmental solutions require a global shift towards a circular economy model. This model emphasizes redesigning products for extended life cycles through reuse, repair, and recycling. It aims to minimize waste and maximize resource efficiency throughout product lifespans. Key components include improved waste management systems and reduced reliance on single-use plastics. Implementing these strategies is crucial for mitigating environmental problems at their source.